Hey everyone, thanks so much for waiting. Since we're at 3 past the hour, we'll kick it off now. Welcome to our webinar on Cadence BYOK. Thank you for taking part of your Tuesday to be with us. A couple of housekeeping notes before we kick it off. I'm Aubrey Bruckner, I'm the head of operations at Cadence, and I'll be moderating today's webinar. This is a mics off session, so please keep yourself on mute for the duration of the webinar. If you have any questions, feel free to drop those in chat and we'll get to those at the end of the session. That said, if you have any burning questions that you want to chat about, we are doing an office hours this Friday. I'll drop the link in the chat for that. So please join us if you're interested in exploring any of these topics further. Also, this is going to be recorded and we'll post it on YouTube as well as send out a link in our weekly newsletter, so keep an eye out for that. Today, we are super excited to be partnering with Modal and Parallel Web Systems on this event, and we have representatives from both organizations here. So we're going to kick it off with just a quick intro from both of those folks to introduce their platform and kind of why it matters for open source research. So first, I'd like to invite Felicia Chang, Developer Relations at Modal, to just give a quick chat on that. Thanks, Felicia.
Awesome. Hi, everyone. It's great to be here. Should I go ahead and share my screen?
Yeah, go for it.
Okay, perfect. Cool. Everyone can see this? Awesome. So yeah, really excited to chat about how you can use Modal with Cadence, and a little bit about like what Modal is and like what we're good at. I guess to start, Modal's AI infrastructure, developers enjoy using Modal because at our simplest form, it's just sort of like a function decorator. You wrap a function with app.function and it runs in the Modal cloud. And so that's sort of like the easiest way to think about Modal. But people end up running a lot of different kinds of AI workloads. So I think a few big use cases, people are doing like low latency inference. We have like features like GPU snapshotting to make that faster. Recently, we've been seeing a lot of use around Modal sandboxes that let you run agentic code in a secure environment. People are using Modal sandboxes to build coding agents and do reinforcement learning. And you can also train models on Modal using features like multi-node GPUs, saving your checkpoints to our Modal volumes, which is like a custom file system. And the great thing about Modal is it's just code that you're running in the cloud. And so all of these different AI workloads can sort of like work together. And so you can train your models and then run inference, or run inference as part of your training, do inference and sandboxes. So all of that's like very flexible in Modal. Some use cases of Modal in like sort of like the science areas, we see a lot of use of Modal for computational bio, just like a sort of like very data intensive workload. There's a case study that we have with Chai Discovery that you can find on our website, on our blog, that talks about how Chai is using Modal for large-scale model training experiments and also doing like inference pipelines for like molecular and protein design. So it's really interesting to see like computational bio take off on Modal. Yeah, we have like a number of like programming specifically for that. And so in our Modal examples, we have a few sort of like comp bio use cases, and you'll also find, a lot of different examples for building coding agents and running inference with different kinds of open source models, all of which can be like portable for the kind of work that you're doing with Cadence. So how to actually get started? We will be providing $150 in Modal credits that will be shared via email after this webinar. But you can also join our community Slack channel to get any support that you might need. Even better, we have some programs that might be relevant to you all. The first is our Modal for Academics, where we provide a larger amount of Modal credits for research submissions. We're currently open for NeurIPS, and you can check out more details on modal.com/academics. We also have a startups program for folks that are in like an early stage startup status, and we're also just beginning to spin up programming in person in SF for the startups program. So actually next Monday we'll be having office hours. So if you're just getting started and want to talk to our team in person, this is a great way to meet us. The event is on our Luma, and you can check out more details on the program at modal.com/startups. Similar to the academics program, we provide large amounts of credits for you to build cool stuff on Modal. And that sort of wraps things up. Really excited to listen in on the rest of the webinar. Thanks for having me.
Yeah, thanks for that intro, Felicia, and thanks for sharing all of like the great resources that might be relevant to our audience. So appreciate that. Next up, we have Utkarsh Srivastava, who's head of engineering at Parallel Web Systems. Parallel, like Modal, is also kind of bringing the K to the Cadence BYOK, so we'd love to have him give an intro. Oh, you're on mute.
Yeah,
there we go.
Hey, Ari, great to see everyone. Thank you for having me. I'm Utkarsh. I lead engineering at Parallel Web Systems. I'm here to tell you a little bit more about our deep research product, which is used by scientific researchers around the world. So basically what the product looks like is you can go to a website and give an open-ended prompt like this, like give me a history of the open web, and any topic essentially that you want to run a deep research on. And then we will essentially scour the web for all information related to that topic and give you a well-presented report on what you want to learn about. And that's kind of the website version of the product. You can also access the same through an API and integrate it into whatever it is that you may be building. So these are two ways to access the deep research product. And just in at a very high level, like what are the things that makes this special, and why do people prefer this over some of the other products out in the market? One is that we have designed these APIs to provide like the highest quality output at every price point. So the way we think about that is like if you were to draw a graph of accuracy, the quality of the output measured on the y-axis, and the cost per request on the x-axis, then we want to be at the Pareto frontier of that accuracy cost curve. So here you see these orange processors, which are sitting at the frontier of that curve, which means that given any cost that you want to spend, we can provide you the highest quality output. This was a benchmark called Deep Search QA, which is a deep research benchmark that has been put out by Google. And here we show that our deep research project performs at a higher quality than some of the frontier labs and even Google itself. So that's one of the biggest reasons for why people prefer this product, is that it can give them really, really high quality. Second, like a little bit behind the scenes of like how do we get that high quality? One of the reasons is that we have our own crawler that goes and deep crawls data from websites that can be really hard to crawl, especially for scientific research. There can be websites that have data hidden behind forms and all sorts of like hard to crawl websites. So our crawler is smart enough to go behind that and get that data, which is then used for these deep research reports. So one example here I pulled out is fda.gov. Here you have some forms or some documents here, and you have these paginated links here, but these are not real links in the traditional sense of the web. These are like JavaScript links, which when you click, it dynamically changes the content of the page. So a traditional crawler won't be able to paginate and get all this content, but our crawler is able to do that, and hence our index is like richer than what you'll find in other places. So that's reason number two. Third is we do a lot of work to provide verifiable outputs with provenance. So we show you how we reached a particular piece of output, and this is done to like minimize hallucinations. So for example, here is a piece of that deep research report that I showed you earlier, which is talking about this particular component called CIM. And here's this like little number 4 here, which is like similar to like what you would find like a citation in an academic research paper. And when you click on that in our UI, you'll get essentially sources of where we got that data from. And we also show like our reasoning, and there's an excerpt from every URL that backs up the claim that we're making here. So every piece of data that we provide has provenance built in. And last but not the least, one of the reasons people love our APIs is that we operate on a fixed cost basis rather than a fixed cost per token. So we are fixed cost per task. So you decide what level of compute you want. Like if you want to spend 60 cents on a deep research report, you go for this processor here, which costs $600 per 1,000 requests. So that's 60 cents per request. And that's the amount you're guaranteed to pay, not more than that. So our whole deep research execution is budget aware and tries to give you the best possible output at that price point. Yeah, so those are the 4 kind of reasons that people kind of love our deep research product. And you started at platform.parallel.ai. There are some credits available for folks when they get started. And we're always happy to learn more about your use case. I saw a question in the chat here.
I think, Prash, if it's okay, we'll save the questions to the end, if that's okay with you.
Yeah, sure.
Thank you so much for that intro. And I think on Parallel's website, if you go and sign up, if you're a new user, you can get 16,000 free searches, I believe, through their API. So there are free credits available for folks who are interested in trying it out. And so to the main event here, we have Timothy Kassis, the CTO of Cadence, here to give us a tutorial on Cadence BYOK. And we'll get to see how tools like Parallel and Modal are put into action through the platform. Without further ado.
Thank you, Aubrey. Thank you, everyone, for coming. We're excited to give you a quick overview of what we call Cadence BYOK. Just a 30-second introduction to the company. So Cadence is an SF-based startup. We're focused around building AI co-scientists for use by any science domain, really, everything from biology to chemistry, physics, astronomy, etc. And we have a paid product called Cadence Web. But what this talk is about is our open source version of that, which is called Cadence BYOK. And then again, BYOK here stands for Bring Your Own API Key. So to get started, this is kind of my high-level agenda. I'm going to really kind of use the slides more of a basis for kind of open-ended discussion. I do ask that people leave kind of most questions until the end, but if there's something that you guys want to elaborate on or ask about my slides, please go ahead and post them in the Q&A and we can quickly answer them. It really doesn't need a slide to kind of explain to scientists out there and researchers that research really has a human bottleneck. If you are a scientist or really any type of person doing research, think financial analyst, if you're doing sort of due diligence, even if you're researching what to buy as your next dishwasher at home, there's really kind of this fundamental bottleneck that humans reach. There's actually a bunch of them. I'm quickly going to mention 4 main ones here. Multi-domain synthesis basically refers to the idea of how well can a typical expert in the field basically bridge different domains. So if you're a trained chemist, for example, you might be really good at chemistry, but you might be completely blind and have a lot of blind spots when it comes to physics or biology or kind of the financial aspects of what you're building or working on. And that's a human limitation. No single human can actually learn all these fields at the same time to an expert level. A lot of people right now are really kind of heavily using chatbots to kind of augment the human research process. So think things like ChatGPT or Claude.ai or Grok. but they have kind of fundamental limitations in terms of what they can and cannot do. So for example, they can tell you how to use a certain Python package or how to use a certain script, but they won't actually do it on your behalf. So there's still kind of that human bottleneck when it comes to execution. The other aspect to all this is a lot of the platforms out there are really kind of limiting in the fact that you're locked into a certain model provider or capability or API. For example, if you're using Gemini for your kind of research tasks, you're really limited to what Google offers in terms of search. You cannot use powerful systems like Parallel. And same goes for compute. You cannot use things like Modal, for example, for scalable compute. And lastly, as a human researcher, you tend to have a lot of ideas. And unfortunately, in most cases, you can only execute on these ideas one at a time because you need to be doing a lot of research. You need to be writing code, executing it, running experiments in the lab, synthesizing results, getting feedback, etc. My guess here is, a typical scientist probably has around 10, 15 ideas at a time going through their head. And in an ideal world, you'll be able to execute all of them kind of simultaneously without having to wait on kind of your mental load to go down. So this brings the question of what agents can do for science. And I think there's a lot of discussion right now and conversation in the scientific community of what are AI agents actually useful for in the general scientific domain. And I think 2026, we're going to see an explosion of these AI agents being used in life sciences, especially, I would say, but also in physics and chemistry and other disciplines, including clinical research. So the main difference when we say, an agent versus an LLM, an agent basically means it's an LLM, it's a large language model that has agency, so it can do things on your behalf. And the main differences here between something like ChatGPT or Copilot and an AI co-scientist like Cadence BYOK is that these kind of AI co-scientists built on these agentic systems can take action. So they can go to websites, they can query databases, they can write code for you, they can execute it and iterate over it. They can do multi-hop reasoning. For example, they can pull literature from different databases. They can pull certain molecules from a database. They can look at your own data and really combine and synthesize across these different modalities and data sources. And then obviously, one important thing with things like Cadence BYOK with kind of scalable compute provided by Modal is you can assign whatever compute you want for the complexity of the task that you're actually working on. So for example, if you're having the co-scientist train a machine learning model for you, you can easily assign it a very large kind of GPU instance via Modal and have your system kind of train that model on that. Same goes for Parallel. You can really integrate kind of top-notch search results in your AI co-scientist, which you cannot typically do with things like chatbots. And then lastly, Cadence BYOK runs locally. It runs on your computer. So your data actually stays local. You're not uploading your data files to a third-party provider. And you've probably heard of this idea that Anthropic kind of released a few months ago called agent skills. Originally, it was a concept. Then they kind of materialized it into something called Claude skills. And now it's become known as this open standard called agent skills. And essentially what agent skills are, they're a human-readable written description that you can provide to an LLM or an agent, and the agent knows, based on its context, when to use that particular skill. For example, you might have a skill that you write in your lab that describes a certain computational protocol or computational process that you want to follow. And you give that skill to your agent, and then your agent can essentially do it on your behalf. So skills have become now very ubiquitous. They're supported by every platform out there, including Claude Code, Cursor, Codex, Gemini CLI, and of course, Cadence BYOK. We as a company at Cadence, we actually open sourced a very popular repository called, it used to be called Claude Scientific Skills. Now it's been rebranded to Scientific Agent Skills. And it's currently being used by about 150,000 scientists worldwide, including at several kind of big pharma, big biotech companies. And it completely adheres to the agent skills protocol. So that basically means it's also compatible with things like Cursor, Claude Code, Codex, Gemini, CLI, etc. But really what I want to talk about today is how we essentially package these skills in a more kind of user-friendly user interface for scientists. So if you don't know how to use Claude Code or Cursor, we are essentially building Cadence BYOK specifically for you as a scientist end user. Now, what Cadence BYOK is, essentially it's a open source package that acts as a kind of high-level interface to scientific agent skills. And it provides a lot of functionality for the typical scientist. So one is it allows you to select whatever model, and I'll show a demo, by the way, on all this in a few minutes. But it allows you to select any model that you might be interested in. For example, if you feel that Opus from Claude is typically a good model for your scientific discipline, or if you are kind of lean towards Gemini or even NVIDIA Nematron or kind of other models, you can select any of them for execution. The whole idea behind Cadence BYOK is this expert delegation concept. So essentially what Cadence BYOK acts as is a high-level orchestrator, and it has access to these kind of experts that it spins up on the fly. And these experts have access to all of the scientific agent skills. And they can kind of execute on your behalf. For example, if you're doing a bioinformatics task, Cadence BYOK might spin 2 or 3 different experts. One might be a bioinformatician, another might be a data analyst, another might be a data scientist, and they all kind of jointly work on the given task that you gave it. We've also integrated, we've heard this a lot in terms of feedback on our paid product, Cadence Web, but a lot of scientists wanted just some built-in workflows instead of this kind of open-ended nature when it comes to an empty chat box. So Cadence BYOK has about now 325 different workflows. Essentially, they're one-click workflows, which again, I'll show you how to use in a second. But they address a lot of scientific tasks, everything from writing papers to creating graphical abstracts to very complex analysis, deep learning model training, literature search, etc. So Cadence BYOK runs locally. It runs on your own computer. You can execute the code locally, or you can actually outsource it to a Modal instance, which I'll also show you how to do. And it has full parallel integration. So all the tasks that you're actually doing, they're grounded in actual real-world sources. And you can do things like web search, deep search, data enrichment, using the Parallel API all through Cadence BYOK. This is a kind of a high-level architecture for how the system works. I'm not going to go through details here. The only reason I put this here is because we're recording a video, so this might be useful for people later on if they want to watch the video. The other thing I did not mention is Cadence BYOK also supports custom MCPs. So if you have an MCP that you use with your own data or some additional functionality or third-party providers, you can integrate it into Cadence BYOK. The workflows, they really cover almost every scientific discipline, everything from genomics to scientific communication. And we even have workflows focused around things like due diligence or financial analysis or quantum physics, etc. And I really kind of encourage you to actually try them out. Now, what's really unique about workflows is we benefit a lot from the community. So anyone can actually contribute a workflow and optimize it for Cadence Web and scientific agent skills. Now, to get started with Cadence Web, it's actually very easy. We would love feedback, by the way, if there is a way we can even simplify this a bit more. But we try to make it and structure it in a way where a non-coding scientist is able to quickly and easily install it. It's just a 3-step process. So you download the repository, or if you're familiar with Git, you can Git clone the repository. You add your API keys. So this includes the Open Router API key, which is required for LLMs, but also optionally your Parallel and Modal API keys. And then you just type start.sh. And that essentially runs, and opens something that looks like this. So this is the primary user interface for Cadence BYOK. I'll quickly give you a high-level overview of what you're actually looking at. So on the left, we have what we call the sandbox, and this is all where your files lie. Any file that you upload, any file that the system creates for you, any deliverables, any outputs, they're all in the sandbox directory on the left. In the middle is a full-fledged file preview and editor. So you can look at coding files like Python scripts. You can look at LaTeX files. You can even compile and edit LaTeX files, similar to if you've used Overleaf before. This has kind of almost the full functionality integrated. And of course, you can view things like image files, CSVs, various scientific formats as well. For example, 3D molecules, etc., can all be viewed in this editor. And then here on the right is the main chat interface, and I'll go through this in a second. And we also have the workflows tab, which I'll also explain kind of quickly as well. So the chat interface has a few kind of unique features that I think makes it pretty versatile for most kind of use cases. So there's a few kind of things you can actually select. So one is you can select your model of choice. Our recommendation generally is to go with some of the frontier models like Opus 4.6 or Gemini 3.1 Pro or even GPT-5 5.4. But obviously, you have a very long list of choices. And really, a lot of the models available from OpenRouter are also available in Cadence BYOK. We limit them a bit because these are models that we've actually tested that work well and reliably with things like skills and tool calls. Some other models might not be as reliable, so our recommendation is to go with whatever is on this list first. You can also optionally add data sources. So here, there are about 229 databases that the system can immediately access. When you select them, they essentially get added to your prompt, and the agent knows that it needs to select them. And we'll look at a few examples as kind of time permits. And the other kind of two interesting things here, compute. So if you have a specific task that requires heavy compute, for example, you are training a machine learning model, or you're doing running a bioinformatics pipeline, thanks to the infrastructure provided by Modal, you can essentially select whatever custom compute that you want here. And you're just paying based on usage, billed by the, I believe, either second or minute. But please correct me, Felicia, if I'm wrong. So what's really interesting here is as you're working through your tasks, you might decide that every task might require different compute. So every task gets executed on a different instance based on whatever compute that you actually are asking for. And then skills, there's immediate access to all of the scientific agent skills. So again, this is a kind of a highly popular and community-supported set of skills for scientific research. Most of these skills are typically automatically selected by the agent when it needs to perform a particular task. But you can also be very explicit about it. Like, let's say you really wanted to use this diff-doc skill. So you select it, and then when you kind of input your prompt, it makes sure that the agent actually utilizes the skill based on your needs. That was kind of the chat interface. The workflows are actually really cool because they simplify a lot of common tasks. For example, here you might want to create an infographic, let's say. And when you click a specific workflow, it shows you what that workflow is actually about. So it tells you this is kind of the prompt it's going to use. You can upload specific files. So if I upload a file right now, it's going to ask me to select, for example, I'm going to upload this paper that one of my interns wrote. And then here is the skills that is actually going to tell the agent to execute this on. And here I can also select which model I want this workflow to run and what compute I want this workflow to run on. And we'll look at an example in a few minutes as well. And the workflows really cover a whole host of topics, everything from scientific communication to genomics. I think a lot of attendees here are doing some sort of genomic research, chemistry, and so on. And some workflows require you that you provide data either in your sandbox or you just upload it and it gets added to your sandbox. And usually are some certain variables you might need to kind of elaborate on. But other workflows might not need data at all. For example, solubility prediction here. It just asks you what smiles are you interested in. OK, so that was kind of the workflow overview and the chat overview. Now let's look at a few kind of potential examples. Now, while we're doing that, I want to familiarize you with the interface a bit more. So here we had uploaded a PDF document. And if I click it, I can view it in my viewer. And sorry for this being small. I'm actually sharing here my laptop screen, which makes this a bit squished. But the file preview here allows you to essentially preview any type of common file. I'm being very careful not to use every type because there are some file formats are not supported, but most file formats are. And it allows you to also edit files. So you can change whatever you want to change and then save it. And then that becomes immediately available to the agent for it to use. Now, when you're working on certain tasks, thank you for all the questions, by the way. I'll start answering them maybe in about 5 minutes. So when you're working on a certain task, you can drag and drop certain files for context. So for example, I can drop this and say, create a graphical abstract, or let's actually go with some kind of more relevant example. Can you review this paper for me? OK, and then what's happening right now is the model basically understood that I'm referring to this PDF that I wanted it to review, and it's spinning up an expert. And that expert is essentially, well, actually a few experts. So one expert it spun up was an expert to do the PDF parsing. So essentially to transform it into a format that the agent can read. And it's doing that right now. And then in a bit, it'll spin up another expert that's actually going to do the review. So we'll see that live. So while that's happening, let me kind of elaborate on what's actually happening behind the scenes. So the experts, they essentially run an instance of Gemini CLI. So you've probably heard of Claude Code. Google has their own version called Gemini CLI. And Gemini CLI essentially acts as a, think of it as an independent execution agent. And the main agent orchestrator, so for example, Opus here is telling Gemini CLI, I want you to convert this paper, or I want you to review this paper. And based on that, the Gemini CLI executes. So this delegation strategy, the reason it's actually very powerful is the orchestrator can spin up multiple experts in parallel, so multiple Gemini CLI instances. And each Gemini instance has its own fresh context. So essentially, it's a lot more efficient. There's not a lot of contamination from kind of other tasks that are happening. And it allows you to also select whatever model you want for the executor that's independent from the orchestrator. So the executor right now, by default, we have it set at Gemini 3.1 Pro, because we noticed that Gemini CLI works really well with Gemini Pro. But the orchestrator in this case is Opus 4.6. And here in the UI, you can actually see what's happening from the kind of expert delegation end. So there was the conversion process. There was the conversion to Markdown, which is what the agent can read. And now it's actually being reviewed by the agent. So let's wait for that to happen. And while that's happening, let me actually show you some installation instructions. So I know we've been trying to make this as easy as possible to install for scientists, but it's still a bit confusing. So let me just kind of clarify what's happening. So if you go to the GitHub repo, you'll notice that there's essentially a section called Getting Started. And in Getting Started, you'll notice that there's a kind of few steps that you have to take. So step number 1 is you just have to download the repository. You can either git clone it or literally just go here on the green button and say download zip. And then once you do that, you're going to see that there's going to be a file here called environment.example. Here is where you provide, here's where the K comes from in BYOK. So here you get to provide your own API keys. So one required API key is the Open Router API key, and that gives you access to a lot of the LLMs that run Cadence BYOK. And another API keys that we highly recommend for the system to work really well is parallel search. And again, you can go to parallel.ai, create an account, get an API key there, and Modal. So Modal has these kind of two keys that you have to provide, something called token ID and something called token secret. But again, if you're attending the session, you're going to get $150 worth of Modal credits, and we'll send you instructions also in terms of how to kind of create these API keys and put them here. In addition to that, everything here is optional, but because there's a high reliance on the scientific agent skills, some of the skills might require their own API keys as well. For example, with NCBI, if you provide your API key, that gives you kind of more research power, that you don't hit any rate limits. There's things like Rowan. If you use Rowan or Adaptive, kind of for protein engineering or AdGene, you might want to provide your API keys here. And if you have a Zotero library as well, etc. But these are all optional. They don't really kind of stop you from using the system at all. And then in terms of how do you start it? So once you add your API keys, let me go back to the getting started. Once you add your API keys to the .environment file, you just type /start.sh, and that basically spins up the entire system. And your browser opens up, and it will look like this, essentially. OK, so now the task is continuing. You'll see that the agent decided to spin up several reviewers. So it spun up a scientific reviewer. It spun up a writing quality reviewer. It spun up a methodology reviewer, a citation and reference reviewer. And this, for example, uses Parallel behind the scenes. It spun up a logical consistency reviewer. And just to be clear, none of these reviewers are actually hard-coded into the system. So Opus decides what type of reviewers it needs for this task, and it automatically creates that agent and writes the prompt for that agent for it to behave as that reviewer. And we can see kind of intermediary outputs here. Let me open this. So these are kind of the sources of data it's looking at to validate the information that's actually available in the paper. And we'll look at the final results when kind of this task execution is done. OK, and while this is happening, again, I want to show you here our scientific agent skills. And the reason this is important is if there are particular functionalities in Cadence BYOK that you think are important for your type of work, the scientific workflows you execute on, your team, your company, you can actually come here and contribute your own skill. So once you contribute a skill, that becomes available for you to use within Cadence BYOK. And we have a lot of community contributions. We have actually 25 pending requests right now that we need to review. But this is a very active community, and it's growing pretty fast as well. So I encourage you to contribute here to the open source ecosystem. OK. So this particular task is Opus decided it needs to do some very rigorous reviews here. So we'll let it kind of finish. But let me show you some of the other kind of workflows that are pretty interesting. So for example, some of the workflows are relevant to really everyone is paper.
We can still see the GitHub. Can you switch back to the Cadence screen?
Yeah. So one of the workflows that a lot of people find interesting is around kind of paper and manuscript preparation. So I think everyone here either writes a paper for external publication, if you're an academic, or even internal use if you're working at a company. And so we created a bunch of workflows focused around paper writing, and they all use a lot of the scientific writing capabilities that are in scientific agent skills. A lot of them, we've actually optimized the prompt specifically around Claude scientific agent skills. So for example, you'll notice in this case that this is a prompt specifically focused around writing a discussion section, and it calls 3 types of skills. It calls our scientific writing skill, our research lookup skill, and parallel web to essentially ground everything that it's saying in real data. And the same goes for kind of a lot of these skills. So while that's actually executing, can we are we able to take some questions now? I think there's a lot of questions in the chat. I want to get to all of them.
Yep. I think this is a good time to take some Q&A. So I think the first question we got goes back to your slides where it had the diagram of how Cadence BYOK functions. And the question is, from the diagram you showed, it seems like the agent and the skills for the system live on a remote server, and hence the request and data is processed remotely. Is that true?
So that is not true, actually. So the actual skills technically live in GitHub. But what happens is when you start the Cadence BYOK, they're downloaded from GitHub locally, and they become locally available.
Go ahead.
The only thing that actually does need kind of access is, obviously here you're using LLMs, right? So if you're using a third-party LLM, because you can also use your own local LLM. For example, if you have OLLAMA installed, you can use a local open source LLM. But if you have a third-party LLM you're using from Anthropic or OpenAI or NVIDIA, etc., then that LLM is being called externally. That's not running on your machine.
And I think a related question from Audrey, who asks, can you share how you keep user data private and secure? So can you comment on data privacy and security in the context of Cadence BYOK?
Yeah, so Cadence BYOK runs on your own laptop, right? So data, your data files don't go anywhere. This is all local. For Modal, sometimes if you're using Modal, your data might be sent to the Modal instance. Your code will get executed on that data on the Modal instance, and then the Modal instance is essentially killed. It doesn't persist. But I'll maybe if someone has any Modal specific questions, I'll have Felicia maybe answer that as well.
All right, and another question, are you connected to any primary research or data collection pipelines yet?
Primary research or data collection pipelines. So with Cadence BYOK, no. So Cadence BYOK is basically a lightweight version of Cadence Web, which is our hosted platform. There's no proprietary data access or connections. Cadence Web is a different story, but we can talk about that later. Really, the focus here is on this kind of open source package right now.
And I think the other question we got was actually about Cadence BYOK versus the Cadence platform. Which scenarios would you recommend using? BYOK versus the hosted platform. Can we address that briefly?
Yeah, very good question. So Cadence Web is essentially our hosted platform that's paid. It's pretty expensive to run, but it's extremely capable. For example, it can do very kind of rigorous end-to-end tasks from start to finish. You give it your data, it will do literature search, it will come up with hypotheses, it will execute on it, it will do analysis, computational simulations, all of that, and end up with a paper essentially ready to submit. With Cadence BYOK, it has access to a lot of these capabilities, but it doesn't really do anything end-to-end. You literally have to sit here and talk to it. You tell it, okay, I'm going to do literature search. Now I want you to make sure that you address kind of this field that you neglected. Now I want you to do this kind of experiment. So Cadence BYOK is really, think of it as a powerful tool that just sits on your desk while you're doing your work the entire day. Cadence Web, it's kind of set it and forget it. You give it your task, you go, you go do something else for a few hours, and you come back with your result.
That makes sense. And that was all the questions we had in the chat. If anybody else has other questions, feel free to drop them in the chat. We do still also have Felicia and Utkarsh on the call, so if you have questions about Modal or Parallel, feel free to ask. All right,
okay.
let's talk about, oh, sorry, we have one more question.
Yeah, so the question is, can you set a custom LLM for the expert? The question is yes. Sorry, the answer is yes, you can. The reason we don't give that capability directly in the UI is we're trying to make this as foolproof as possible for non-coders. And let me clarify why that's the case. So Gemini CLI works really well with the Gemini set of models. It's no secret, both are made by Google, so they kind of support each other pretty well. You could technically have the Gemini CLI run any model you want, including local models through Ollama. And it's one file you have to change, which I'm happy to kind of explain offline to anyone that's interested. And you can have Gemini CLI run any model. The issue with that is you'll have a deteriorating performance if you run something other than Gemini at this time. So that's why we kept it non-customizable, just so we remove any kind of the burden of making these choices on the scientists. Again, this platform is really designed for non-coders, like people who just want to quickly set this up and start using it without having to worry about what model should I be using for Gemini CLI. How do I do X? How do I do Y? That's kind of the goal here.
And we have a question from Kevin who asks, is the end-to-end bigger project scope the primary strength of Cadence Web?
I would say not the only primary strength. So Cadence Web has a lot of optimizations when it comes to how it uses scientific agent skills. It's a multi-agent architecture where we have a lot of reviewer agents that essentially look at the results and ground it in real-world data. So we use heavily things like parallel web and other service providers to give you a very minimal level of hallucinations, way less so than other platforms out there. So that's kind of one big advantage. The other big advantage is we have some like additional capabilities in Cadence Web. For example, writing and slide generation and paper output is a lot better in Cadence Web than it is just using the kind of the raw skills on their own. And it's really about just a kind of this orchestration layer that we added to Cadence Web.
And a question from Reza who asks, does Cadence factor in the required compute or memory resources required for each task and suggest the appropriate GPU resources to allocate?
So yes and no. So we actually had an initial system where we had an agent decide what modal instance a particular task needs to run on. But we found that giving the agent the decision-making power was not very cost efficient, because sometimes, for example, if you're trying to train a deep learning model, let's say you're trying to train a new or fine-tune like a protein model, then your agent would recommend that you run this on an H200 instance, but maybe that's beyond your budget, or maybe having something like let's say the L4 might be more relevant for a particular task. So we decided not to use an agent to actually do that and have the user decide on their own. Yeah. But it's a good idea. Maybe what we could do is have the agent offer a recommendation, and then the user choose whether to go with it or not.
And we do have a couple of other questions that are kind of more about the nitty-gritty technical aspects of Cadence BYOK, as well as functionality of Cadence Web. For the folks who are asking those questions, I would invite you to our office hours on Friday at this time. I'll drop a link in the chat right now. Please do register and answer. Like, our team will be able to kind of give you one-on-one personalized advice for your use case. Okay. And I want to make sure that we don't run out of time, but let me tell you kind of what we have planned for Cadence BYOK. So what we're really after here is we want to put a AI co-scientist on every scientist's computer. I mean every, like, from the US to down under in Australia. Whether you're an undergraduate researcher or a full professor, or you're working at Amgen or Novartis, we really want to empower you with these agentic systems for science. So that's what we're after. BYOK is essentially our way to reach as many scientists as possible. So having said that, in order for us to make the system very powerful and usable for day-to-day scientists, we really need your feedback. So we've been actually getting a lot of feedback through conversations we've been having, one-on-one conversations with scientists. But if there are certain features you would like to see, please let us know. We're very quick when it comes to execution. Mention them in GitHub. Shoot us a message on our Slack community channel. Shoot us an email, any way that you prefer, and give us feedback.
But generally speaking, what we're trying to do is support really kind of every common ask that we get within the next kind of few weeks, essentially. And some of these improvements include everything from make it a bit easier for people to run local models through Olama. That's a request we've been getting a lot. Another is kind of end-to-end task execution. So similar to Cadence Web, but maybe something a bit more kind of cost efficient for the end user. You've all heard of this auto research thing that came out by an AI researcher called Andrei Karpathy. So Cadence actually uses something very similar behind the scenes, but we want to make it a bit more explicit. So where, for example, as scientists, you might define your end goal, a certain metric, and then the system autonomously works using all its capabilities to optimize, everything for that certain metric that you're after. And obviously, we want a lot of feedback in terms of the UI. A big focus of BYOK is not necessarily capabilities, because you can give these agents to Claude Code and have very similar capabilities. The emphasis is we want a UI that scientists actually enjoy working in, enjoy spending hours and hours of their day actually working in. So if you have suggestions or feedback, please definitely let us know. And then I do want to end on kind of a few notes here. So one is, Cadence BYOK is a small part of the key kind of Cadence ecosystem. We have a lot of open source packages. We're going to be open sourcing a lot more. We have a self-serve, fully hosted platform called Cadence Web as well that we encourage you to sign up to. And for enterprise customers, we have something called Cadence Enterprise, which I won't go into right now. And Aubrey actually just reminded me as well, if you're an academic, or if you work in a nonprofit research institution, we do have a very, very generous program for Cadence Web. So please apply on our website. Essentially, it gives you 90% off the Cadence Web plan for your entire team. And then this is our team. We are a very small team. We're very nimble. We're very agile. But it really enables us to kind of work quickly in terms of developing this ecosystem. And lastly, please do connect with us on GitHub, star our repos so you can stay in the loop in terms of changes. Follow us on X, subscribe on YouTube, and follow us on LinkedIn as well. And let's see if this finished. And you should never have an agent do a live demo, because they always decide to do their own thing whenever they want. So typically, for example, in a task like this, where you're asking to review a paper, the agent might decide to spin up, one reviewer. But in this case, it decided it wanted to be a bit more rigorous and spun out a bunch of reviewers. And by the way, the reason these are taking time is they're calling parallel web behind the scenes, and they're doing a lot of literature search to validate everything in the paper. But you get really powerful results, essentially, way more than things like pasting your paper in ChatGPT or Claude Code and asking it for a review. Okay, should we end on a few questions, Aubrey?
If we had any other questions, except a comment from Dan, who asks for Cadence Web dark mode, please.
Cadence Web dark mode. Okay, yes. So Cadence BYOK, by the way, has dark mode.
All right, Dan, give Cadence BYOK a try when you have a chance. To wrap up, I would love to just give a final shout out to Modal and Parallel Web Systems for their support of this event today. Thank you, Felicia and Utkarsh, for joining us. We will be following up with attendees after this event to send out that code for the $150 in Modal credits, so keep an eye out for that. And again, we have office hours on Friday, so if you decide to try Cadence BYOK today and get stuck and need some help, join us. Our team will be there to give you live one-on-one support. Thanks so much, everyone. Enjoy the rest of your Tuesday.